It's very common at this point in the semester for you to have not covered the appropriate theory in class before you have to do the Kirchhoff's Laws experiment. That's okay. The experiment was designed for you to be able to do it anyway, but if you're finding things confusing on the pre-lab, there is an optional help video posted on the website that gives you help with the concepts of voltage and current. If that's not enough, please get in touch with your lab instructor and ask them to give you more help. You're going to be building 3 circuits in this experiment, and the first one looks like this in your lab manual, but I've printed it out like this because it's going to correspond better to the circuit that I'm going to physically build in front of you. So just understand that what you see in your manual looks like this, and I've just twisted it 90 degrees to make it a little clearer in this video. Now the first thing you want to do is to set up your power supply, and we want the current to be maxed out and the voltage set to 12 volts. You've got 4 knobs here, and in both cases there's a coarse adjust and a fine adjust. So the top 2 are for the current and the bottom 2 are for the voltage. The current knobs you can twist all the way to maximum, and with the voltage knobs, use the coarse adjust to get close to 12 volts, and then use the fine adjust to fine-tune it exactly. So you do this the best you can, but we are actually never going to use the numbers on the power supply as our data. Instead, we're always going to take data using these multimeters. Now, what I find is easiest when it comes to building circuits is to build them very, very methodically and sequentially. So you go from the positive terminal on the power supply to the next circuit element, which is the switch in our case. And once that's hooked up, then we go from the switch to the 50 ohm resistor and so on. And just work your way very methodically, very sequentially, one step at a time through the whole circuit. I find that's best for making sure you don't confuse yourself. So let me show you this now. There's 3 plugs here on the power supply. One of them's a positive terminal, one's a negative terminal, and then there's a ground in the middle. The ground and the negative terminals are actually connected electrically. They've got a metal bracket between them, so you're going to use just the positive terminal and the negative terminal. So to begin with, we connect the positive terminal of the power supply to the switch. So positive terminal to switch. And then after the switch, we go to the 50 ohm resistor. So switch to the 50 ohm resistor. And then from the 50 ohm resistor to the 100 ohm resistor. And from the 100 ohms to 120. And finally, from 120 to the negative terminal of the power supply. And then, if we push down the switch, you can actually see that there is a current flowing in the circuit now. By the way, if at any point you feel confused and you're not sure whether you built the circuit right, it's always okay to ask your lab instructor to come check it for you before you start taking data or pushing down the switch and running electricity through it. So as I said, you'll use your multimeters to take data. The multimeter can be used to measure either voltage or current, and we're using a DC power supply, so there's 2 V's on here, a V with a squiggle over it and a V with a straight line. The V with the straight line is for DC voltage. Likewise, to measure current, we go to the A for amps with a straight line over it, so down here. I'll just turn that off for now. You're always going to have one wire plugged into this COM terminal in the middle. If you're measuring voltage, you want the second wire on the left. If you're measuring current, you want the second wire on the right. Now to measure voltage, I'll use this DMM. It's fairly simple. You have 2 wires and 2 terminals, and you just plug the wires in across whatever you're interested in. So if you want to measure the voltage across this resistor, you take your 2 wires, plug them in across the resistor's 2 terminals, and then we set this to the V with a straight line over it. And when I press the switch, I get a voltage on the multimeter. And by the way, if you see a minus sign, that only means that you plugged in your wires backward, but it's not a big deal. You can just ignore the minus sign. So again, for measuring voltage, if you, for example, want the voltage across the power supply, you just plug in your 2 wires across the 2 terminals of the power supply and push down the switch, and you should get a value. Now you'll see that this reads 12.13 instead of 12.0. That's the reason why we use these DMMs rather than the numbers on the power supply. The DMM is actually a lot more accurate than the power supply is. Now, measuring current, you can actually do it at the same time as you measure voltage, but to keep things simple, I'll do it on its own. You'll notice I only have one wire plugged in. That's because the other wire will come from the circuit itself. Measuring current is a little more confusing looking, so I'll try to go through this carefully so it's clear to you how this works. When you want to measure current, you basically have to interrupt the current in the circuit and force it to go through the multimeter before it continues on where it was supposed to go. So say I want to measure the current going through this resistor. The current goes into that resistor through this wire. So I unplug that wire and I force that current to go into my meter instead. And once it's been through my multimeter, then it's allowed to continue on where it was supposed to go. So it's like I took that wire that had been there, snipped it in half, and put my multimeter in the middle. So the current must go through the multimeter before it's allowed to go where it was supposed to go. Again, use the A with a straight line over it, and then you push down the switch and we measure the current. And to show you again, if you want the current coming out of the power supply itself, you'd say, okay, the current's coming out of the power supply through this wire. So I interrupt that and I force it to go into my meter instead. And once it's been through the meter, then it's allowed to continue on its journey. So it had to go through the multimeter first. And again, hold down the switch and take the reading. So now I'm ready to build the second circuit, and as before, what's in your manual looks like this, but I've turned it 90 degrees because that will better match what I'm physically building. Now I recommend you rip out all the wires before you start a new circuit. I just find it's very easy to confuse yourself when you're trying to change connections, and it's much better to pull everything out and start from scratch. Now the last circuit we built was called a series circuit because all the elements just hooked one after the other in one long series. This one's called a parallel circuit because these resistors are connected parallel to one another. I find what's easiest when it comes to hooking up a parallel circuit is to hook up this inner loop first, so just this one, very methodically like before, one after the other until you're done. And then, once you've hooked up that inner loop, hook up the next one. And once that's finished, hook up the last one. So that tends to be the least confusing way to do it. Hook up the inner loop first, then add the second loop, then the third one. So let me do this now. I'm going to move this off to the side. So to begin with, again, we start from the positive terminal to the switch. So let's do that. So positive end to the switch. And then from the switch, we go to the 50 ohm resistor. And then from the 50 ohm resistor back to the negative end of the power supply. So one big loop right there. So that's the first loop. And now I'll hook up the next loop. So that uses the 100 ohm resistor. And I hook up positive end to positive end and negative end to negative end. So positive to positive and negative to negative. So now they're hooked up like that, or maybe this is clearer. So that's the second loop. So now I add the last loop, which uses the 120 ohm resistor. And again, positive to positive, so positive to positive, and negative to negative, negative to negative. So they're all hooked up like that, and like this, and like this. And again, if you're not sure if you did it right, call your lab instructor over to check. So now we take measurements off of this. With voltage, again, you've got two wires and two terminals, so you want the voltage across this resistor in the middle. It would be a case of take your two wires and plug them in across the two terminals of that resistor, like that. Push down the switch and get your value. And again, current is a bit confusing, so I'll show you again. If you want the current going into this resistor, you have to interrupt the current that was going in here, force it to go through the meter first, and then it's allowed to continue on where it was going. So the current is going into this resistor via these wires. So you unplug these, put them into the meter, and so the current is forced to go through the meter first, and then it's allowed to go on where it was supposed to go. So like that. And then again, push down the switch and get your value. And likewise, if you wanted the current coming out of the power supply, you interrupt the current, force it into the meter, and then it's allowed to continue on where it was supposed to go. Now this is the third circuit, and I'm not actually going to build this one for you. But I will note that again, the easiest way to build it is to hook up this inner loop first, one circuit element after the other, and when that's all hooked up correctly, then add the second loop. Now the first circuit we built was called a series circuit. The next one we built was a parallel circuit. This is a combination circuit. We've got some circuit elements in series with one another and some in parallel with one another. So again, if you're not sure whether you hooked up your circuit right, feel free to ask your lab instructor to come over and check it before you start taking data.